Welcome pre-cal students to class today on Wednesday, December 4th. Hope you guys are doing well. Hope you're ready to learn some math today. Go ahead and get out all of your stuff while I'm going over announcements here. You'll need your notebook, your books, calculators, and be ready to take some notes today. First of all, there will be a test this Monday. If you're not going to be able to make that, please let me know. No later than Sunday, please. No later than Sunday. And when you walk in the door on Monday, announcement number 2, your integrity sheets have to be completely finished, or at least what you've done has to be filled out. You have to hand me a sheet of paper with everything on it, number 1. And number 2, you cannot do any more work on your homework or videos and get credit for it. So keep that in mind. And I need you to get your tests finished up from a couple weeks ago, okay? Get your tests finished up. And I know a couple of you, I've got one young man coming over today, and I know another one's contacted me about getting some help. So make sure you're staying on top of that, okay? Let me reach over here and get a quick drink, and we'll get started. We are going to finish Chapter 7 today, except for the word problems. We'll look at those tomorrow. I care about y'all. I don't want to scare you. These word problems are really difficult, and I'm going to try to be very fair on these. I'm going to give you probably one for your notes, and then 4 to work on. We'll probably just do them all together in class tomorrow. I'll make sure the one I give you on the test is very similar to the ones we have in your homework, but we'll look at those tomorrow. I want to start off by revisiting the topic of unit vectors, okay? I want to revisit the topic of unit vectors. So go ahead and write down unit vectors for your heading today. The lesson number is 7.6, and the date today is the 4th. Unit vectors, lesson 7.6, and the date today is December 4th. Remember, a unit vector is a vector that has a magnitude or length, whatever you want to call it, of 1, okay? Please remember that. That is what a unit vector is. If a vector has a direction angle of 180 degrees, find the unit vector. Now I want to help you do this, okay? So please take some really good notes and watch what we're doing here, okay? Now, first of all, I don't think we've ever talked about necessarily a direction angle when dealing with vectors, but I think I'm not going to spend a lot of time on these problems because they're so similar to problems we've done in the past. And it's common sense to me that a unit vector, we would start here like we always do, and we would rotate however far we need to rotate, okay? So if I know a vector has a direction angle of 180 degrees, so I'm going to start here and go right here. That means I know the vector is right here on this line, right here. Alright, that makes sense. I rotate 180 degrees, so here's my vector. Now, they just want us to find the unit vector. So we go out how far? A length of what? Well, a length of 1, because a unit vector is a vector that has a length of 1. So that's pretty easy. We rotate 180 degrees, so we know the vector lies on this line right here, and then we know we go out 1 space. So what's the name of that vector? What would that vector be? How would you denote that vector? Well, it would be -1, 0, right? Because you're over to the left, and you're up 0, and you're down 0. So there, you just found a unit vector that has a direction angle of 180 degrees. We rotated 180, and we went out a length of 1. Now you're like, Mr. Earhart, that's really easy because the line fell right on the x-axis, and you're right. The next example we're going to look at is going to be a little more difficult. But do you at least see what we're doing here? You have a direction angle, so you rotate that many degrees, and then you find the unit vector, or the vector that has a magnitude or a length of 1. Let's try another one. If a vector has a direction angle of 225, find the unit vector. Okay, here we go. My direction angle is 225 degrees. Now I know if I rotate to here, that's 180, and I've got to go 45 more degrees. And so if I'm going to rotate 45 more degrees, that would put me about right there. So do you see what I did, students? I rotated 180 plus 45 more degrees to give me a total of 225. So I know my vector is somewhere on this line here, okay? And I know that I want to go out a length of 1. Now I'm going to make it a pretty long 1 so I can see it. So I'll go out to about right here, put a point here, there's my vector, and I'm going to call this black line right here a length of 1. Students, this is not hard at all. I rotate 225 degrees, so I know my vector lies here, my unit vector, and I go out a length of 1. So if this is my vector right here, then all that I want to be able to do is I want to be able to find where this point is. I know that I'm over so far, and I know that I'm down so far. Have we not done problems like this just 100 times this year? Sure we have. So I want to know how far over the point is. That's going to be my X. And I want to know how far down this point is. That's going to be my Y. And if I rotate it 180 degrees, the angle left over in the triangle here is 45 degrees. So what I basically have is a right triangle that looks like this. And this is 45 degrees right here. And this really long side here has a length of 1. And this is going to be my X, and this is going to be my Y. So very quickly, I can use sine and cosine. Sine of 45 degrees is opposite over hypotenuse. Opposite over hypotenuse. Here's my right angle. And of course, using cosine, I would say cosine of 45 degrees is adjacent over hypotenuse. Adjacent over hypotenuse. Multiply both sides by 1, and I would simply get sine of 45 equals y. Multiply both sides by 1, and I would get cosine of 45 equals x. Now, 45 degrees should be one of those angles that's on our table. And I don't have the table in front of me, and I apologize for that, so hold on just 1 second, and I will get that answer for you. Square root of 2 divided by 2. So the sine of 45, if you look on your table, the sine of 45 is square root of 2 over 2. And the cosine of 45, by the way, is square root of 2 over 2. So that equals your y, and that equals your x. So you can pause the video if you need to. I'm going to erase all this for a second right here. And I want to talk to you guys. I want to review. I rotated 225 degrees. I drew a really long line. And then I said to myself, okay, I'm looking for a unit vector, so I'm going to go out a measure or a length of 1. And I know there's 45 degrees inside the triangle. So if I want to find this vector, how I can denote that or write that vector, I need to know how far over this point is. That's my x. How far down is my y. So my x, now don't forget you went to the left, so it's going to be negative square root of 2 over 2. And then you went down, so it's going to be negative square root of 2 over 2. So there we go. You did it. You found a unit vector that has this direction angle right there. Okay? Not too bad. Let's try one now that's in radians, which really is not a big deal, but very quickly. If a vector has a direction angle of 5 pi over 6, find the unit vector. Well, first of all, 5 pi over 6, if you convert that correctly, is 150 degrees, okay? 150 degrees. So we're going to find a unit vector, and we're first going to rotate 150 degrees. So there's 150. So if I rotate 150 degrees, there's my vector. Now remember, I want a vector that's going to have a length of 1. So I'm going to go ahead and put a point right here. And I'm going to call that a length of 1. Okay, and now let's go ahead and find or solve this triangle. Here's my ordered pair, and I want to find how far over I am, that's x, and how far up I am, that's y, and I rotate 150, so this is 30 degrees right here, 30 degrees. So once again, I would have sine of 30 equals opposite over hypotenuse, cosine of 30 equals adjacent over hypotenuse. Multiply both sides by 1, and we're left with sine of 30 equals y. Multiply both sides by 1, and we're left with cosine of 30 equals x. Now, if you look at your table that you have, you know that the sine of 30 equals 1/2, and the cosine of 30 is square root of 3 over 2. Okay? So, this is your y value, this is your x value. So, I'm going to have to write this a little, I'm going to scribble this off here. I'm going to write it really big up here so we have more room, and I'll draw an arrow. So I know I went to my left, so my x value is negative square root of 3 over 2. I know that I went up, so my y value is a positive 1/2. So there, you did it. This ordered pair right here, I'm highlighting with my pen, has these values right here. These values represent a vector that has a length of 1, it's a unit vector, that has a direction angle of 150 degrees, okay? We've done 3 of those, that's pretty good. Hopefully you'll be able to get the hang of this as you work on your homework. But it's really not that hard. It's really not, okay? Now let's continue on. Write down finding direction, angles, and magnitude. I think this is our last topic, so I'm pretty sure it is. Not a super long video today at all. Finding direction, angles, and magnitude, lesson 7-6, and the date today's the 4th. Okay, now this should look really weird to you. I know we've never seen a vector written like this, but let's not get really worried about it. I mean, it's obvious by cosine of 150i and sine of 150j. Remember, when you write a vector with I and j, you're writing a vector as a linear combination, like 5i minus 6j. That would be a vector written as a linear combination. We learned how to do that yesterday. And so when you see this, it really kind of should be common sense. I mean, all they want you to do is rotate 150 degrees. So rotate 150. And then draw your vector in such a way that, what is this number on the outside right here? It's a 6. So we know we have a length of 6. Oh wow, do you not see how easy this problem is? In this problem right here, I want you to find the direction angle and the magnitude. Now, I should have written that down. I apologize for not doing that. Find direction angle, dA direction angle, and magnitude. Well, students, when the vector is written in this form here, and we do not have a certain name for this, it's just a vector written with a direction angle and a magnitude on the outside. Do you not see when the vector is written like this? How far over did you rotate? 150 degrees? Yes. So the direction angle is what? Yeah, you got it, 150 degrees. It's that easy. And isn't the magnitude the length of the vector? Yes, it is. What's the length of this vector? 6. So the magnitude is 6. So there's really no work to do on this problem. Whenever I give you a vector written in this form right here, you can automatically right away see the direction angle, 150 degrees, and you can right away see the length of the length or the magnitude of the vector is the number on the outside here, so the length is 6. That's really, really easy. Let's try one that's a little more difficult, okay? What if I gave you a vector written in component form and I said find the direction angle and the magnitude? Find the direction angle and the magnitude. Now students, this is really, really pretty simple. I mean, it is. We've done so many problems like this where we draw the triangles and we find the angle on the inside and we find the hypotenuse, etc., etc. But let's go ahead and do one. So just to make sure we've practiced. Okay, we know we're going over -2 and -8. Do you see how I do that? I do not try to count 2 little units and then 8 units. I want a nice big fat triangle that I have a lot of room to work with. So I know it's -2, so I go to the left, -8, so I go down. I don't care if my triangle is drawn to scale. That's really not a big deal to me. I just want a lot of room to work with, okay? So there's my vector. So I'm going to go ahead and draw my right triangle like I always do. And I know I've gone over 2 units and down 8 units. And this is my right angle right here. Now, think about it. If I want to find the direction angle, that means I better find this angle right here inside the triangle. And if I want to find the magnitude, then I better find the length of this line right here, which is your hypotenuse. Well, let's do that one first. That's easy. The length of the hypotenuse would just be take one of your legs, square it, take one of your legs, square it, add them together, and take the square root of that, Pythagorean's theorem. So 8 times 8 is 64, 2 times 2 is 4, 64 plus 4 is 68, so we're looking at the square root of 68. Now, you can break down 68, so you need to do that. You need to get in the habit of doing that. 4 is a perfect square, because we know the square root of 4, and 4 goes into 68 evenly. 4 times 17. Okay? So we cross off 4 times 17 is 68. So I cross off the 4, and the square root of 4 is 2. So I put a 2 on the outside. So there's your magnitude. I'm going to write it right underneath the word. Well, I'll come over here and put magnitude equals, or I guess the right way to write it mathematically would be put a line, put u, and put a line. Magnitude of u equals 2 square root of 17. So there, I found the magnitude. Okay? Now, let's find the direction angle. And of course, in order to find the direction angle, all that I have to do very quickly is just use these two sides here, 1, 2. The names of those two sides are opposite and adjacent, so I know I'm going to use tangent, and I would say tangent of angle theta equals opposite over adjacent. Opposite over adjacent, or in other words, 8 over 2. Well, if I simplify that, I'm going to get 4. 8 divided by 2. Now remember, you're looking for an angle here, so you type into your calculator second tangent, and then 4 equals, and you will get 76 degrees, rounded of course. So this angle right here is 76. So I rotate. The direction angle always starts here and always ends on the hypotenuse. So I rotate 180 degrees plus 78 degrees, and that's going to be 256 degrees. So my direction angle, 256 degrees. And I'm doing that in my head. I'm checking it. Yeah, that's right. Okay. So there we go. I mean, we've done problems like this all the time using writing complex numbers in trig form, solving trig types of problems, whatever. And so all we do is find the hypotenuse, which is your magnitude, and then find the angle inside the triangle, and then find the direction angle all the way around. So not too bad. Okay. We've done a lot of this stuff before. Okay. So finding direction, angles, and magnitude of vectors. Let's continue on. Okay, this is our last topic here, and so I was wrong earlier when I said the other one was our last topic. This was the last topic. It's a pretty simple topic, so I don't think anything we've covered has been extremely long or extremely difficult, but I would like you to write this in your notes. We're going to finish up today by finding angles between vectors, lesson 7.6 still. And this is the last topic in chapter 7, except for the word problems we'll look at tomorrow, finding angles between vectors. Now, I would like you to write this in your, well, I'll tell you what, you do not have to write this in your notes. You do not. Just watch, okay? Finding an angle between two vectors can be very time consuming. Please watch carefully. Here's one vector going this direction. Here's another vector going this direction. If I asked you to find the angle between these two vectors, I would be referring to this angle right here between the two vectors, okay? Now, in order to find that angle right there, do you realize what you'd have to do? First of all, you'd have to draw a triangle over here, and realize that you're over 3 and up 7. And then you'd have to find this angle here. We'll just call it angle X inside your triangle. Then over here you'd have to draw a triangle like this. You'd have to realize you're over 4 and you're up 2 and find this angle here. We'll call it angle Y. And then you'd have to realize from here all the way to here is 180 degrees. So you'd have to take 180 degrees and subtract out your X angle and then subtract out your Y angle. And then you're finally left over, we'll call this angle Z right here, and then you're finally left over with your answer. Now that's not a ton of work, but that's a pretty good amount of work. I mean, you have to draw the triangle, use tangent, draw a triangle, use tangent, and I would love to get into the proof of where the formula comes from that I'm about ready to show you, but we're not going to have time for that. It would make the video a good, probably 15-20 minutes longer, but there is a formula. After all this work that I've just showed you, it definitely takes a lot of time. And so what I want to show you is when you're asked to find an angle between two vectors, there is a formula we can use, okay, thankfully. And it allows us to find the angle between vectors pretty easily. And that formula is this. Go ahead and write that down. Cosine of the angle you're looking for, we're going to call it theta. And this is the angle you're looking for. Cosine of theta is, here's your two vectors, u and v. Now, the two vectors that you're using might not be u and v. It might be x, y, z, a, or b, or whatever. But whatever the two vectors are called, you take the dot product of the two vectors, put that number up top, find the magnitude of u, find the magnitude of v, multiply them together, put that in the bottom, and then take the cosine inverse or second cosine of that number to get the angle. And it's really that simple, okay? So having said that, let's do a problem together, okay? All right, here we go. Write this down in your notes. I want you to find the angle between these two vectors. Now I guess we'll call one vector u and we'll call one vector v, okay? First of all, let's find the dot product that goes up top. So my formula says cosine of theta equals, now up top will be my dot product. Remember how to do that? You take first number times first number, that's negative 12. You take second number times second number, that's 14, and then put a plus sign. You're going to add these two numbers together, and obviously you're going to get 2, okay? You're going to get 2. So there we go. We learned how to find the dot product quite a few days ago, so I've got a 2 up top. Now we're going to find the magnitude of u. Well, the magnitude of u is, of course, the square root of 3 squared plus 7 squared. So 3 times 3 is 9. 7 times 7 is 49. And you're going to get 54. The square root of 54. So there. I found the magnitude of u just like that. Okay? And now let's find the magnitude of v. So I'm going to square my negative 4. I'm going to square my 2. And of course I'm going to get 16 plus 4, which would be 20. Now you're like, well, Mr. Earhart, you better simplify that radical. Normally I would, but are we not just going to type this whole thing into our calculator anyways and get out some decimal? We are. So I'm not really worried about leaving or worrying about that radical, okay? Now, be very careful how you do this, okay? Everyone's calculator is a little different. If you have a graphing calculator, my recommendation is, I'm trying to think of the easiest way to do this. I would personally, myself, students, take the square root of 54 and hit enter, and then hit times the square root of 20 and hit enter. So that way you have your entire denominator already as a decimal, and you're not going to be off hardly much at all if you round that to 4 decimal places. So I'm going to go ahead and put 32.8633. Now that's just me. I think it's better to first of all simplify your denominator, and now just simply type into your calculator 2 divided by 32.8633. So if we do that correctly, we're going to get cosine of theta equals 0.06085800619, and I'm looking for an angle, so now I hit second cosine of that decimal, and you're going to get 85.6. I'm going to go ahead and put 87 degrees. So there. Now you'll get pretty fast at that, okay? Not that difficult. I mean, all that you're going to do, to me, I'd much rather do this than all of this work back here where you're drawing two triangles. First of all, you got to graph the vectors, then you got to draw your triangles, then find the angles and all that kind of stuff. To me, it's just very quickly dot product, then magnitude, magnitude, and then type into your calculator. 87 degrees. Okay, so not too bad. This is our last. I have two more up here. I think I've taught long enough. Let's do one more and we'll just stop. I won't do the last problem. Okay, so you can work ahead or you can watch me do this however you want to do that. Let me grab a quick drink here. And let's go ahead and work on this last problem here. Okay, let's find the angle between these two vectors. Well, first of all, you find the dot product. So you multiply -3 times -5, that's 15. And then you multiply -3 times 2, that's -6. And we add those two numbers together. We're obviously going to get a 9. So the top of my fraction will be a 9. That's not too bad, guys. Pretty easy. Now, to find the magnitude of this vector here, it would be, well, 3 squared is 9, 3 squared is 9, add them together, and you get the square root of 18. Now let's find the magnitude of this vector. Well, if you square -5, you get 25. If you square 2, you get 4. Add those together, and you get 29. And of course, look at your formula right here. Over here is cosine theta equals. With my calculator, personally, I like to get the square roots out of the way. So I'm going to type in square root of 18 times the square root of 29. And if you do that correctly, you're going to get this right here. You will get, I'm going to cross this off, and I'm simply going to put 22.8473192. Okay, and now with your calculator, type in 9 divided by this number, and you'll get something close to this, 0.393919296. And now, because you're looking for an angle, second cosine of that decimal, and you're going to get 66.8, so I'm going to call it 67 degrees. And there you go. You found the angle between these two vectors. Okay, pretty cool. Now, here's what we're going to do. Some of you might feel like, hey, I've got it. I'm ready for my homework. Fine. Then fast forward this next problem. Those of you that are still a little shaky on this, you'd like to see one more example, then go ahead and watch this example. So for those that want to watch this, watch it. For those that don't, then go ahead and fast forward to the end of the video where I give you the homework problems right here. Okay? All right, here we go. Let's find the angle between these two vectors. So the first thing we do is we find the numerator, which is the dot product of two vectors. So first number times first number, that's -4. Second number times second number, that's -8. And we're going to add those two numbers together. So the numerator will be -12. Very easy. Alright, next what we're going to do is we're going to find the magnitude of this vector. I square my -4, that's 16. I square my 2, that's 4. Add those together, and you get the square root of 20. I'm going to find the magnitude of this vector. So I square my 1, 1 times 1 is 1. Square my 4, 4 times 4 is 16. Add those together, and you get the square root of 17. And of course, all of this equals cosine of theta equals. Okay, with my calculator, I'm going to very quickly type in the square root of 20 times the square root of 17. And you're going to get this decimal right here. I'm just going to go ahead and cross these off. And you're going to get 18.43908891. Okay? And so now with your calculator, I would type in 12 divided, or -12, don't forget the negative sign, -12 divided by this number. And if you do that correctly, you're going to get -0.6507913735. Okay, and now we're looking for an angle, so you hit second cosine of that decimal number, and you will get 130.6. So I'm just going to put 131 degrees. There we go. Okay, just not that difficult. Hope you've grasped the math today. Okay, if you have any questions, don't hesitate to call or email me. And let's see how long this assignment is. I know we have 4 problems right here, 49 through 52. Here it's odd. That would be 5 problems, and then 1 problem here, and then this would be 3 problems here. So 13 problems. That's pretty reasonable. You should be able to finish that in a reasonable amount of time. I would start your homework now. I would start your homework now. I would work the entire assignment out. Then I would check your answers in the back of the book. For the even answers, I would check them with the video, and then any problems you miss, watch the video and let the video help you find your mistakes. Okay? Hope you guys have a good day today, and I will talk to you guys on Thursday tomorrow.